Hi guys, I miss you. I can't wait to come back next week. Sorry that I've been out, but I have no choice. Anyway, rather than just having you sit there doing nothing, I thought I would create videos, so we're going to see how this goes. Please bear with me because I made a video for geometry last night and that didn't turn out so great. So anyway, let's get started. So we're going to talk about intersections of lines and planes, okay? And a line can intersect a plane at a point. It could intersect at infinitely many points, or it could not intersect at all. So let's talk about those, and then we will do some examples, one for each, and then move on a little bit, okay? So if a line intersects at a point, well, of course, the picture looks like this one. When we have a line intersecting at infinitely many points, and that just means that the line lies on the plane. And in fact, the normal vector, which I drew there, that's the normal vector will be perpendicular to that line because the line is on the plane and the normal is perpendicular to the plane. So every point on the line will be on the plane, but the converse of that is not true. Not every point on the plane would be on the line. So planes are made up of many points. So that might be an IB question at some point, so just keep that in mind, that the converse of that is not true. All right, and then if the line is parallel and distinct, well, it's not going to lie on the plane at all. Okay, so the picture is going to look like that one. All right, so I've got a paper under here because the ink shows through on the video. So let's look at some examples, okay? Before we do, I went ahead and I wrote down the steps, and here's a little trick that you would need to show the grader anyway, and you're going to find it strikingly similar to what we did with the plane equations. Take the dot product. You're going to use the direction vector of the line, and you're going to dot it with the normal to the plane or normal of the plane. And if it doesn't equal 0, then that's good. The line and the plane are going to intersect at a distinct point or a unique point. If it does equal 0, then the line's either going to be on the plane or parallel to the plane. And we're going to use knowledge of Algebra 2, I guess, to determine which one it's going to be. So you'll remember that when we get to an example like that, all right? But essentially, you take the dot product, okay, to figure out, does it equal 0 or not. Regardless of whether it does or not, you're going to write the parametric equations for the line. You're going to substitute those into the equation of the plane for x, y, and z. And then you're going to solve for the parameter to see what's going on. All right, so let's look at the first example. We want to find the intersection of this line with that plane, if it exists. Okay, so I went ahead and I just move that a little bit. I dotted the direction vector of the line with the normal components, the normal vector to the plane, and I got 0. So unless I screwed up in my arithmetic, so if I did, you can let me know. So anyway, I got a 0, so that means it's either going to be, the line's going to be on the plane or it's going to be parallel to the plane, parallel and distinct. So I went ahead and I wrote my parametric equations for the line. And then I took those parametric equations in for the line, and I substituted them in for x, y, and z into the equation of the plane, and I cleaned the mess up. And what I got on the left-hand side was 0 times lambda is equal to -3. And let me get rid of that. I don't really think we need it for this one. It's just a habit. Anyway, so I don't care what number you choose for lambda. If you plug that in, that number times 0 is not going to give you a -3. So that's just going to mean that you have no solution. If you think back to Algebra 2, when you had, one solution, no solution, or infinitely many solutions, you would get something weird like this, like 0 times some variable is equal to a number. Okay, so no solution here. That means there's going to be no intersection, and that means that the line is going to be parallel and distinct. Capiche? Next example sorry. The next example, we're going to do the same thing. We're going to try and find the intersection between a line and a plane. So I went ahead, dotted the normal vector with the direction vector of the line, and I got an 8. Great. That means that the line and the plane are going to intersect at a unique point. So I'm going to go ahead and I wrote out my parametric equations of the line, substituted them into the equation of the plane, and I solved for lambda. Now on the IB exam, a lot of times they're going to ask you to find the point of intersection. No problem. If you have lambda, all you have to do is plug it in for these little parametric equations here, and you can find the point. So I went ahead and I did that. I plugged in a -1/2, and again, hopefully I didn't screw up on the math. I did this kind of fast to get it done with, but anyway, 1 + 1 is 0. Threw in a -1/2 there, got a -1/2 and 5/2. So provided my arithmetic's correct, the point of intersection between the line and the plane would be 0, -1/2, and 5/2. Okay, another example. So again, we have a line and we have a plane, and when I dotted the normal and the direction vector, I got 0. Wrote out the parametric equations, substituted them into the equation of the plane, and ooh, I got 0 times lambda is equal to 0. Now, this I do want to state for my grader. Lambda is an element of the reals. Okay, so you probably know that already, those symbols. But the point is this, is that I can take any number I want and plug it in for lambda and multiply it by 0 and get 0. So lambda can be any real number, and what that means is that there's going to be infinitely many solutions, and therefore the line will lie on the plane. Now the next thing you're going to be asked to do is to find the angle between a line and a plane, and I'm going to keep these videos short just because I think one of the problems I had uploading, it took like 15 hours and then it didn't come out right, is because it was 25 minutes long, and I don't know if that matters, but anyway, I thought if I kept the video shorter, maybe it would work better, so that's my plan. So this is the end of the lesson. The angle between a line and a plane. So I drew my plane here. This orange line is the line. It's intersecting the plane at this point. Here's my normal vector. I can have a direction vector u parallel to this line L, and you know, this is the bottom of the plane here, so I just put that to show that like that's the bottom of the plane. But anyway, there's an angle here between the plane and this line, and oftentimes we want to find it, and it's super simple to do because you already know the cosine formula, and this is pretty much the same thing except we're going to use the sine. All right, so we usually want to find this little angle here between the plane and the line. You could also find this angle here. There's also an angle between here and the normal, but generally speaking, you want to find this one here. But these two are complementary anyway, and so, you know, they add up to equal 90 degrees. So you could find the other one if you needed to for some reason. But the angle is the arc sine of the dot product between this direction vector, which I'm calling u, and the normal, divided by the respective magnitudes. So here's the equation of a line, the equation of a plane. They want us to find the angle between them, all right? So what I did was I took the components of the direction vector of the line and the normal, and I dotted them, and I got that it equals to 1. So I plugged it in right here into the formula. The formula is on your formula sheet. I found the magnitudes for u and n, plugged it in, threw that in my calculator, and got about 8 degrees. Okay, super simple. And your homework or classwork is going to be super simple. You're going to do page 606, 1 through 4, all. I still need to cover the shortest distance between a point in space and a plane, which is the perpendicular distance, of course. But anyway, I don't want to run through the video, and I want to do that separately. So that's what I'm going to do for Friday, all right? So if you have any questions, post them on EDSB regarding this, and I hope this worked out. I'll talk to you anyway on Friday. Have a good day.